Okay, in this video we're going to talk about zeros and multiplicities of polynomials. So let's look at our first example. So we look at this and it's already in factored form for us, which makes it much easier to identify all three factors. And we know if we want to find zeros, we're going to take our factors and set them equal to 0 and solve. So my very first 0 is a -2. I'm going to take my second factor, set it equal to 0, and I get 4, positive 4. And then my last 0, 2x minus 3, or last factor, I'm going to set that equal to 0, and I get x is equal to positive 3 over 2. Now multiplicities tell us how many times that 0 or that factor occurs, and that's easy enough by the exponent. So remember that exponents are a shorthand to multiplication. So I could write this as x plus 2 times x plus 2 times x minus 4 times x minus 4 times x minus 4 times 2x minus 3. And you can see how cumbersome that is. So it's much easier to use exponents. So x plus 2, that factor appears twice, so the 0 appears twice. The factor x minus 4 appears 3 times, so the 0 is going to appear 3 times. And 3 over 2 it has an exponent of 1, so that's 1. So remember with a multiplicity 2, that's a bounce. Remember that's that even quadratic. It's going to have that quadratic feel to it. 4 is the snake. So remember that's going to look like your cubic graph, any odd degree. And 3 over 2 appears just once, and that's just a regular cross like you're used to seeing in most of your functions that you've dealt with up to this point. You see just a straight cross, no multiplicities. Number 2, the exact same thing. I have x squared is equal to 0, so x is equal to 0. X minus 7 equals 0, so I'm going to add 7 to both sides, and I get that x is equal to 7. X plus 2 is equal to 0. So I have x is equal to -2. So I have my 3 zeros. For multiplicity, I'm going to look at that power. So it appears twice. So my 0 has a multiplicity of 2. The factor appears 5 times. That's a multiplicity of 5. And the factor appears 4 times. So it's a multiplicity 4. So remember, on an even multiplicity, we get that bounce. Again, as a reminder, it's that quadratic look, that parabola look. 5 times is an odd, so that's a snake. Again, that cubic look. Okay, remember that x to the third and x to the fifth looks similar. The fifth is just much skinnier. Okay, and of course another even is going to produce that bounce. Again, that quadratic feel. So one more time, we have x minus 1 is equal to 0. Add 1. So x is equal to 1, so that's my 0. Factor, set it equal to 0, and solve is going to give me my 0. So I have a 0 of 2. And then my last factor, x minus 3, is equal to 0. Add 3, and I get x is equal to a positive 3. So the factor appears once, so that's a multiplicity 1. The factor appears twice, so that's a multiplicity 2. The factor appears 7 times, so that's a multiplicity 7. So remember, once is a regular cross like you're used to seeing. An even multiplicity will result in a bounce, and an odd multiplicity will result in that snake. Okay? Now the same idea can be applied to a graph. Now we're going to assume the multiplicity is the least. And we can write a general as well. Okay, so, and I'm going to explain that in just a second. So let's look at our zeros first. So I know I have a 0 at 1, and I have a 0 at 3. Now I see I have that bounce, so I know that in general, that is an even. It has to be even to produce that bounce, and the least that it could possibly be is 2. Now it could be 2, 4, 6, 8. It's hard to tell in these polynomials how skinny this might be, how narrow. So we're just going to assume we know that it's even, and the least that it could possibly be is a multiplicity 2. So 3 we have that snake. So this is that bounce of an even. So here we have that snake, and that lets me know that in general it has to be something odd. It can be 3, it can be 5, it can be 7, but it has to be something odd. So the very least, at the very, very least, it has to be a multiplicity of 3. Okay? So let's look at the next one. So again, let's identify our zeros first, and then we'll discuss multiplicity based on the effect. So we have a 0 at -1, we have a 0 at 0, and then we have a 0 at +1. Now based on the effect at -1 is a snake. So again, I know that it has to be some kind of odd multiplicity, and we're going to say that at the very least it has to have a multiplicity of 3. Now it could be 3, 5, 7, 9. We just know that it's odd, and at the very, very least it has to be 3. So 0 is a nice straight cross. So that has to be a multiplicity 1. There's nothing else going on there. Again, the same thing with 1. It's a multiplicity 1, so it has to be a straight cross. Okay? So we're going to look at the same kind of thing, but I want you to kind of think about the end behavior stuff that we talked about. So for a 0, remember, for an even degree polynomial, either the ends go up, up, or down, down, based on it being a positive or negative leading coefficient. And odd matches the right-hand side. So if it is a positive leading coefficient, then the right hand is going up. If it is a negative leading coefficient, then the right hand is going down. And remember that odd are always in the opposite directions. Okay? So let's look here. So we know we have a 0 at 0, we have a 0 at 1, and we have a 0 at 2. Okay? So to figure out the least degree, we need to know what the multiplicities are here. So we know that this is an even multiplicity because it has that bounce. So at the very least, it's a degree 2. This is a cross, so that's a 1. And this is a cross, so that's a 1. So when we multiply, remember we add our exponent. So 2 plus 1 is 4. Okay, now we should have expected this to be even because both of our ends are going in the same direction. And because they're both going to the positive, we know that our leading coefficient must be positive. Okay? The last one, exactly the same idea. So I know I have a 0 at -1, and I know I have a 0 at +1. Okay? Now this is a bounce, so I know that it has to be even. And to figure out the least degree possible, I know that if it is an even, the smallest it could possibly be is 2. Now it could be 2, 4, 6, 8, but it asks for the least degree. At 1, we have that snake, which tells us it's an odd degree. So at the very, very least, this is a 3rd degree. Now it could be 3, 5, 7, but we want to know the least degree. So the smallest possible degree this polynomial could have is 2 plus 3, which is 5. Now again, we should have expected this to be an odd degree as our end behavior goes in opposite directions. So we also know that with an odd degree, the right-hand side is what matches our leading coefficient. So because the right-hand side is going down to -infinity, I know that my leading coefficient must have been negative.